The sun produces more energy in 1 second than we use in years, and so why can't we copy it? Every single second, the sun releases more energy than humanity uses in years, and scientists are trying to recreate that power right here on Earth. This is the dream of nuclear fusion, near limitless potential energy. But there's one problem stopping us from achieving it. At its core, fusion is simple. Take two tiny atoms and smash them together, but even the fuel is a challenge. But here's the real challenge. Atoms naturally repel each other like two magnets. To make fusion happen, we have to push them so close that nuclear forces take over. Releasing a massive amount of energy. In the process, a small amount of mass becomes pure energy. This is what powers every star in the sky. Fusion is the opposite of nuclear fission. Fission splits heavy atoms. Fusion builds from light ones. Quick test. Which process powers the sun? A, B, C, or D? Think fast. Correct answer B, fusion. But here's where it gets crazy. We have to go hotter than the sun. Smashing these tiny atoms together releases more energy per unit mass than any chemical reaction on Earth. But how do we achieve it? Why? Because we don't have the sun's massive pressure. We have to make up for it with raw heat. At these temperatures, matter turns into plasma. Plasma behaves differently because it responds to magnetic fields, but this creates a huge problem. How do you hold it? Scientists use a tokamak. It uses powerful magnetic fields to trap the plasma in a donut-shaped cage. Because no material on Earth can touch plasma this hot without melting, we hold it using invisible magnetism. Scientists recently achieved short bursts of net energy gain, and this is where most people completely misunderstand fusion. Sustained power is still our biggest challenge. Most fusion experiments fail within seconds. Keeping this reaction stable is the ultimate fight against physics. In labs around the world, scientists spend years trying to hold this reaction for just a few seconds. If we succeed, we get near limitless potential energy with almost no carbon and very little waste. And no, it's not like a bomb. If anything goes wrong, the reaction simply stops. It is far safer than fission. Final challenge, where does fusion fuel mainly come from? A, B, C, or D? Ready? A, coal, B, uranium, C, hydrogen, or D, oil? Don't get this wrong. Correct answer, C, hydrogen. Abundant, but some fuels like tritium must be carefully bred. We are trying to build a star on Earth, but even now, we're still missing one final breakthrough. If we succeed, it could transform how we generate energy forever. The same force that lights up the stars could one day power your home. The future is being built right now. If fusion worked tomorrow, would your electricity bill drop to zero? Tell me yes or no below. If you love learning, follow Learn with Adeesha. Something amazing is coming next. See you there.